Metals and nonmetals. Metals and nonmetals are two major categories of elements. They have distinct physical and chemical properties that define their uses and significance in daily life. This chapter explores these properties, reactivity, and applications with real-life examples. Physical properties of metals and nonmetals. Physical properties of metals. Lustrous. Metal like gold and silver have a shiny surface. Malleable. Metal like aluminum and copper can be beaten into thin sheets. Ductile. Metals like gold and platinum can be drawn into the thin wires. Good conductors of heat and electricity. Copper and silver are excellent conductors. High density and strength. Iron is used in construction due to its strength. Sonorous. Metals produce a ringing sound when stuck. Solid at room temperature, except the mercury, which is liquid. Physical properties of nonmetals. Non-lustrous. Except for iodine, nonmetals are not shiny. Non-movable and non-ductile. Carbon and sulfur break easily when hammered. Poor conductors. Non-metals are like sulfur and phosphorus do not conduct electricity. Low density. Non-metals are generally lighter. Brittle. Non-metals break instead of bending. Here are some real-life examples. Cooking utensils are made of metals due to their good heat conductivity. Electrical wires are made of copper due to its high electrical conductivity. Graphite, a non-metal, is used in pencil as it is soft and can mark surface. Here are some questions and answers. Why are metals movable but non-metals are not? Metals have free electrons and flexible atomic structure, allowing them to bend, while non-metals have rigid structure that break under the stress. Which non-metal is a good conductor of electricity? Graphite. Carbon is a good conductor of electricity due to free electrons. Chemical properties of metal and nonmetals. Reaction with oxygen. Metals react with oxygen to form metal oxide, which are basic. For example, 4Na plus O2 produce 2Na2O, sodium oxide. Nonmetals react with oxygen to form acidic or neutral oxide. For example, C plus O2 produce CO2, carbon dioxide. Reaction with water. Metal react with water to form metal hydroxides and hydrogen gas. For example, 2Na plus 2H2O produce 2NaOH plus H2. Nonmetals generally do not react with water. Reaction with acids. Metal react with acid to form salt and hydrogen gas. For example, Zn plus 2HCl produce ZnCl2 plus H2. Nonmetals do not react with acid as they lack free of electrons. Reaction with bases. Some metals react with bases to produce hydrogen gas. For example, Al plus NaOH produce NaAl2 plus H2. Nonmetals do not usually react with bases. Here are some real-life examples. Rusting of iron is a reaction between iron, oxygen, and water. Baking soda, a base, react with acid in food, releasing CO2 gas, making cakes fluffy. Here are some question and answers. Why does sodium react vigorously with water? Sodium is highly reactive and releases hydrogen gas rapidly, causing an exothermic reaction. What is the nature of metal oxide? Most metal oxides are basic except amphoteric oxide like aluminum oxide. Occurrence and extraction of metals. Extraction of metals. Metals are extracted from ores through different methods. Metals of high reactivity extracted by electrolysis, for example, sodium, potassium, etc. Metals of medium reactivity extracted by reduction, for example, zinc and iron. Metals of low reactivity extracted by heating, for example, gold, silver. Refining of metals. Electrolytic refining is used to purify metals like copper. Here are some real-life examples. Gold is extracted using cyanide leaching. Aluminum is extracted from bauxite ore using electrolysis. Here are some questions and answers. Why is aluminum extracted by electrolysis? Because it is highly reactive and cannot be reduced by carbon. What is an ore? A mineral from which a metal can be extracted economically. Corrosion and prevention. What is corrosion? A gradual destruction of metals due to chemical reaction with their environment. For example, iron plus oxygen plus water produce rust, Fe2O3, H2O. Prevention of corrosion. Painting prevents direct contact with air and moisture. Galvanization. Coating iron with zinc to prevent rusting. Alloying. Mixing metals to enhance properties. Example, stainless steels. Here are some real life examples. Bridge and ship are used galvanized iron to prevent rusting. Aluminum foil do not corrode easily due to their protective oxide layer. Why does iron rust but aluminum does not? Aluminum forms a protective oxide layer preventing their further corrosion. What is a galvanization? Coating iron with a thin layer of zinc to prevent rusting is called galvanization. Alloys, mixture of metals with improved properties. For example, brass is a mixture of copper plus zinc. Bronze is a mixture of copper plus tin. Stainless steel is a mixture of iron plus carbon plus chromium. Stainless steel utensils do not rust easily. Here are some important question and answer. Why are metals good conductors of electricity? Due to the presence of free electrons. Why is sodium stored in kerosene? It reacts with the air and water. Which metal is used in making aircraft and why? Aluminum, because it is lightweight and strong. Why is carbon used in pencil? It is soft and slippery. Conclusion. Metals and nonmetals play a crucial role in our daily lives. Understanding their properties and reaction help us use them effectively in industries, construction and technology. By knowing their occurrence and refining process, we can utilize them efficiently for various applications.